Okay, so I'm going to work you through some of the graphing problems on your 4.2 homework and talk to you about there's two types of graphs you're going to find in section 4.2. Or actually, I guess you're mainly going to work on the exponential graph in 4.2, and then you're going to graph its inverse a little later in the chapter, so I'll come back to you on that. But in 4.2, you're graphing the exponential function, and so you may have a fraction base raised to an x power. This counts as an exponential function. When it's a fraction base, it's a decreasing function, like on C or D. It's one of these. And this has no shift on it. There's no vertical or horizontal shift, so it should be in standard form, but it should be a decreasing function, either C or D. Now, how we can tell the difference in these two, let me see if it'll magnify this for us a little bit. Yeah, just a little bit. In standard form, it goes through the point 0, 1, because if you plugged in 0 for this x and did a t-table, any base to the 0 power would give you a y equals 1. So that's kind of the pivotal point when it's in standard form with no shiftings involved. We should see it going through the point. See how that's 0, 1. 0 for x, 1 for y. So D for that. Now C was pretty close, and you might have to kind of blow that up to see that. But the other thing I know about standard form that would also help me choose between C and D is it's a decreasing function, and actually this x-axis should be an asymptote. It should be hovering right above it and not crossing it. It kind of looks like in this graphic here that it touches it, but it actually should not be. There's an asymptote there, and it's kind of hovering above it. Whereas in graph C, it actually crosses right through the x-axis and it goes below it. So that's been a shifted down exponential. It's still an exponential function, but it's not in standard form. It's not as it would be without any shiftings. So that's graph D. Okay, let's look at number 6. Number 6 is really the same question, but it's kind of in disguise. This negative exponent on it would be like a -1 power, which actually flips that 4 to a 1/4. So that is in essence 1/4 to the x power. So very similar to the one we just did. And we learned that in standard form, there's no shiftings again. It's just a fraction base to the x power. That's going to be this graph. Also, when in doubt, you're going to plot points. If you plug in x is 0 and you're doing a t-table, -0 is the same thing as saying 0. There is no real negative or positive 0. It's neutral. So 4 to the 0 gives you y equals 1. So it should be going through the point 0, 1 again. Also, this graph goes through the point 0, 1, you might say. And that one almost looks like it might be. But this is 1/4 to the x. Plug in another point to be sure. If I plug in 1, what happens when x equals 1 over 1? What's the y value? 4 raised to the -1. If you do that on your calculator, you'll get 0.25, which would be 1/4. And that also helps us tell at 1, it's up just a little bit over the x-axis there, 1/4. You could plug in 2, 3, so on, and plot points to tell. Also, you could plug in negative numbers. See what happens when I plug in x is -1. It goes up 4 according to this graph, and that's correct. Notice if you plug in -1 for x, you'd have -1, which would make +1. 4 to the +1 is 4. So that's why at x is -1, we're up 4 places, and you kind of see that works. Okay. Now, this is where you really get into your own graph design more so, and this might shift gears. That's why I wanted to show this video specifically to show you to do this one. You don't get the options of just picking multiple choice, one thing, and then you don't even get the option of kind of drawing in your own graph. You pick up the graph and then use the shifting rules. I believe it's on this one. Okay, let's see. So it is a fraction base raised to the x power, so we just learned that that is a decreasing exponential function, normally going through 0, 1. So it has that shape, even though it's kind of flipped the wrong way right now. And just click anywhere, and that might drive you crazy at first if you don't know that, but it doesn't let you pick where you're going to put the graph. It does not give you that power, I guess you'd say. So you just have to click over here, and it draws it in standard form for you. So notice it's just like the last two examples. It's a decreasing function, a fraction exponential function coming downhill, decreasing, going through 0, 1. That x-axis is an asymptote. It almost looks like it's touching, but it really isn't. The graphics have a hard time with the pixels kind of making it not show that it's touching, but it should be hovering above that x-axis as the x-axis is an asymptote in standard form. All right, then we're going to use this little tool here. And notice it already has your base put in, so don't change that. It knows the base is 1/2. That's input for you. Then we need to know if it's reflected across the x-axis or the y-axis, and that's not happening on any of your homework problems, just on this one. Notice reflections, when you put a negative sign in front of the whole function, it flips it upside down. That's a x-axis reflection. We don't have that. And if you have a negative sign just in front of your x, it flips it across the y-axis, a y-axis reflection. So that's not happening. The stretch factors, that happened with our parabolas back in Chapter 2, Chapter 3 as well. We would put a multiplier in front of our function, and that would stretch. We did vertical stretches back in the graphing chapter before, but that's not happening here, so we're not doing either one of those. We're just using the shifting rules. So shifting rules, the first one is this grouping with x. That's a horizontal shift. Whatever is grouped with the x variable is affecting the x shift, the left-right shift, and it's always opposite, just like it was with our parabola. So these are the same old rules you've used. It will be a -4, and that's our horizontal shift. It moves it back 4 places. And notice it just moves it then. And then the number on the end, the independent add or subtract, those are vertical shifts. And they are what they say. If it says -1, it is -1. So then see how it moved it for us. Then we hit save. I hope I'm right here. Yes, it works. All right, so just wanted you to see that. The follow-up question is about the domain. The domain is how far it goes from left to right, or what could you plug in for x and get a real answer for y. Looking at it, this goes on, and it's going on that way, it's going on that way. The domain is opening left and right without bound. So let me put those infinities, and I know this is what you all deal with all the time. Little details there. Okay, so infinities. Let's see. Oh, look what I did. I put the negative as the second one. I'm sure you all have had to deal with this frustration here as well. Let's see. Yeah, sorry about that. Just experiencing what you experience sometimes there. Now, for the range, it does have a low point there. It has been, normally it hovers above the x-axis, as the x-axis is an asymptote, but where it shifted down a place, it moved that asymptote down one place. So the asymptote is affected by the vertical shift. So now this vertical asymptote, instead of being at 0, it's at -1. And again, that graph, it looks like it is, so I apologize for that, but it's not. It should not be touching that line. So the range has stopped at -1, and it's not supposed to be touching that. So we'll use a parenthesis, -1, and then it's going up, up, up. You know, the graph obviously goes up on the y-axis, so that is the infinity happening there. We always parenthesis in infinity. All right, let's see if we have another one of those. This one lets you do the multiple choice, so I'll skip over that. Let's see if there's another graphing. I wanted to demonstrate that. That may be all for now in this video, but as always, if you have a question on your homework, and you'd like to see an explanation, a video explanation, always let me know.